Right, we always start with the LSB, the least significant bit, the 1 column, just like you do in normal addition. And we just go like 1 and 0 is 1. Move along. 1 and 0 is 1. 1 and 1. Right, well that's actually 2. And in binary, 2 looks like that, doesn't it? A 0 and a 1. So we write the 0 down, carry the 1. In exactly the same way that if you got 5 and 7 to add together, you go, oh, that's 12, so that's 2, carry 1. That's all you're doing. You're just writing it in binary, that's all. Right, so we then get 1, 0 and 1, which again is 2, which is 0, carry 1. Then we get 0, 0 and 1, which is obviously 1, 0 and 1, and then there's zeros. So one of the great things, you will get marks for getting your answer right, but you'll get marks for showing these carries. And we can check it. What's that top number? That's a pattern that you will learn to recognise. 15. What's the second one though? A bit trickier. A 32 and a 4. So when you add those together, you should get 51, yeah? So let's look at this. So we've got 32 and 16 is 48, plus 3 out is 51. So you can easily double check your answer.
Why can't you just do that after?
Because they're asking you to do binary arithmetic and show that you can do binary arithmetic right. If you just like add them up and then write that in binary, that's not what they ask. So you don't get your marks. Oh yeah, but they want to see that you can follow the process. Right, let's have a look at the second one, gents. Right, so this one, a little bit different number. Okay, these are quite big numbers. What's this first number? It's a rooted number. Right, it's 128 plus, and I do it this way, I'll add the 32 because that fits nice. That's 160 plus 64, so that's 224. Right, the next number is everything but 8. So actually you can do it in your head and go 255 minus 8, which is a horrible subtraction. So 2 big numbers. So when we do this one, we should have a problem. So yeah, we'll get overflow. They'll always ask us about that. You can always be suspicious if they get you to add 2 numbers together and they go, what can you tell me about the result? And you go, well actually it's going to be overflow, isn't it? So you know before you start. Right, 0 and 1 is 1. 0 and 1 is 1. 0 and 1 is 1. 0 and 0 is 0. 0 and 1 is 1. 1 and 1 is 0. Carry 1. Then we've got 3, so that's 1, carry 1, and again 1, and then we write in a box, carry. Right. Shh. Gents, the result, we've got 9 bits, we've got overflow, alright, the result is too big to hold in 8 bits. But our answer is the 8 bits. Now, if you've got to be super careful when you're writing these. You might do a load of work in and you might have an answer like that. I would always finish off, answer is, and then I would write out my answer. I've got my working, they can see me working out and they can see that I know it's a carry and it's an overflow. But I've written the final answer out. So that the examiner knows where the answer is. You often, when you're working through binary problems, you might do a load of number lines and all sorts of stuff. So you've got to be careful about clarity. Clarity matters. When I mark the tests, if I have an answer that's all over the place and a mess, I'm going to give it 0. Okay?